In this video, I'd like to talk about the math question of the day for Saturday, June 24th, 2023. And with this example problem, we need to differentiate this function, h of t, and derivatives or differentiation is a topic that's taught in Calculus 1. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start going through it. And we need to find the derivative of this function. And I'll rewrite the function so that we can rewrite this square root as this expression raised to the 1/2 power, since that will make it easier to actually find the derivative. We have 5t squared minus t all raised to the 1/2 power. And notice that we have a product here, so we can use the product rule, and I will just write that very quickly. I will not prove it here, but if we have two functions, f and g, and we take their derivative, since they're multiplied together, their derivative is equal to f prime, the derivative of f multiplied by g, plus the derivative of g multiplied by f. So we'll use the product rule here. But notice we also have a function within a function. This quadratic polynomial, 5t squared minus t, is within the function, the square root function. So we will also need to use the chain rule. And remember that, let's say we have a function k of h of x. We have a composite function, a function within a function. When we take the derivative of this composite function, we take the derivative of the outer function while leaving the inner function the same, and then we multiply by the derivative of the inner function. And this right here is just what we call the chain rule. So we need to use the product rule and the chain rule in this derivative here. So let's actually start computing this. We want h prime of t, the first derivative of h with respect to t. And basically with our product rule, we can call this f and this g. So we take the derivative of the first function, we use the power rule, we bring down the 6, and we subtract the exponent by 1. Then we multiply all of that by the function g, which is just 5t squared minus t all raised to the 1/2 power. Then we add the derivative of g multiplied by f. I'll put f first, t to the 6, and then we multiply by the derivative of this function. Now, here we need to use the chain rule. So the outer function is the square root function, or this function raised to the 1/2 power. So we can use the power rule. We bring down the 1/2, and we keep the inner function as it is, and then we subtract 1 from the exponent, so this is now minus 1/2, and then we multiply by the derivative of the inner function. Let me make just a bit more room. And this is just a polynomial. We'll use the power rule here. We bring the 2 down, we get 10 times t, and we subtract the exponent by 1, so it's 10t to the first, and then the derivative of minus t would just be minus 1. Again, we use that power rule. We bring the 1 down, and then we subtract 1 from the exponent, and t to the 0 is just 1. So this right here is the derivative of our function h with respect to t. And if we want, we could clean it up a little bit or write it in a slightly different form, but there's not too much that we can do here. We'll use a different color. We can write h prime of t. We'll just rewrite this first part. This is just 6t to the 5th. And if we want, we can write this as a square root again. We have 5t squared minus t plus, here we have t to the 6. We could distribute it here so that we have 10t to the 7th minus t to the 6th. All of this is multiplied by 1/2, so it's over 2. And this will also be in the denominator. So let me backtrack there. We'll put the 2 out in front of this expression. It will go in the denominator and become positive 1/2. So we have our square root again, and we have 5t squared minus t. So this is just a slightly different form, but these are both equivalent and they are the derivative of this function h of t.